Hello.
Hello.
All right. Good. I'm glad you could join us. So I'm here in Dubai at the Investment Management Summit meeting. This morning's keynote was by Nouriel Roubini, the Nobel laureate. And I was very pleased to hear him hammer climate change in his 9 points on why he sees a significant economic downturn, increase in inflation, and a stagnancy of growth. And he pointed to climate change as a significant factor in that list. I think he didn't account for all the growth that the economic growth that will come because of the climate change. People working to offset the consequences of climate change. But I was just very gratified that this was, we're starting to see more and more people in the mainstream begin to address this fact. So that was good. And in my panel discussion tomorrow, I'll be talking about that as well. So I did want to mention a few things. So the calculations that Mike and I are doing are with respect to the Q categories. And one of the things that we need to define, and so far have run into some stumbling blocks. Let me see if I can do a screen share. Hang on a second. Okay, so what we're interested in is we've defined what it means to be a sub Q category, and now for the power gadget, I hesitate to say power object. For the power gadget, if I have a sub Q category S1, I need that. Which comes as a pair S1, C1. Is that large enough in terms of font size? Can you guys read that?
Yes, we can.
Okay, all right, good. So I want to define a, hang on, let's see if it'll, start another one then. I want to define a relation P, yeah, I'll just do it that way. So to get rid of both of these. So, oh, it lets me do that. No, thanks. No. I've never done on the grapple on the phone and like this before, so bear with me for just 1 second. All right, here we go. Let's try again. Okay, so I want to define a relation so this is going to be playing the role of the relation that comes with the Q category. So the little p for the power gadget has got to take two sub Q categories and produce an element of Q, right? So there's going to be one sub Q category, say S1, C1, and another Q category, say S2, C2, and that has to produce a an element of Q, but we need.
Greg, we don't hear you. Maybe you've gone on mute. Does anyone else hear Greg?
Nope.
Okay.
Where did I lose you?
Let's see here. So we were talking about, so up on the screen we have, right as you were just typing, what's on the screen is where we lost you, if that helps.
All right, so let me try that again. Okay, can you see the equation at the bottom, or inequation?
Yes. So the very first two parentheses, you had typed that, and that's after two parentheses on the left. That's where
And then
we dropped off.
okay, so all right, so again, just to set the context, the idea is that we've defined what it means for a so given a QCat, say x a q. All right, so q is a quantile, x is a set, and a is a relation, a q valued relation on x. Right, so given a pair, x1, little x1, little x2, when you take a of that, you get a value back from q, which tells you how much they are related, how much in terms of q's order they are related. So then a subquantile of xaq is going to be some structure, say SC, and let's say Q prime, where Q prime is a subquantile. A sub Q category is going to be a triple SC Q prime, where Q prime is a subquantile of Q, and C is a relation on S, which is bounded above by A. So remember, S is going to be a subset of X, so it makes sense to compare them. So that's the notion of a sub Q category. And now to make a power gadget, we would have to have a relation, let's call it little p, that is going to measure the relationships between two sub gadgets, and it has to satisfy transitivity and commutativity. Let me just stop there and make sure you guys can still hear me. Can you still hear me?
Yes, we can.
Yep.
Okay. All right. Good. All right. So there's transitivity and reflexivity. Little p has to satisfy that in the same way that the relation A and the relations C has to satisfy reflexivity and transitivity. So reflexivity in this case is I've got an S1 and a C1 and an S2 and a C2, and an S2 and a C2 and an S3 and a C3, and if we tensor the P of S1, C1, S2, C2 with S2, C2, and S2, C3, then that should be the same. That should be less than or equal to P of S1, C2, S3, C3. So you can view this as a transitivity rule, right? So we're going, if it turns out that the first one is related to the second one and the second one is related to the third one, then you need the first one related to the second one. The third one, right? So that it's at the going in a straight line rather than going through has got to be you've got to be at least as Q as in the straight line as you are if you go through the third. And so you can view it as a transitivity rule, or you can view it as a composition rule, where when you're composing the pairs and you get rid of the middle bit, right? And you can also remember it as kind of the inverse of a metric, right? Or not the inverse, but the opposite of a metric, right? So if you have a metric, then the idea is that if you draw a straight line between 2 points, that's got to be shorter than going through some intermediate point, right? Going through some kind of dogleg or triangle. Before, when you leave S1, you go visit some S2 before you go to S3. So it's kind of like the opposite of a metric. So that's one relation. And now the other relation that we need is reflexivity. So here, what we want is that little p of S, comma, C S, comma, C has to be greater than or equal to K, where K is the unit for the tensor. So those are the two conditions that we are working to try to satisfy. So what we've provided several different potential definitions. Some of them, so that there's some traditional patterns to try, right? So one pattern to try is a convolution style pattern. The other pattern to try is a trace style pattern. The other pattern to try is a kind of like a Feynman path-like thing. So we've tried all of those, and in all three we got stuck, except that we had forgotten a relation. So we were using the previous identities, and we could get to a certain point, and then we would get stuck. But over the weekend, I realized that we were not remembering that C1 and C2 is bounded above by A. And so now I'm going back through the different calculations to see if adding the bounded above by A allows us to make some progress. So that's where we're working right now. Mike has some other intuitions that he's pursuing as well. So we'll get together in an hour and a half and compare notes. But this is essentially what we're working on is to get these get this relation defined, and that will complete the picture that we've been drawing of these Q categories as a different kind of container for the logic, container such that we can define the interpretations for the quantifiers. So that's the piece of the puzzle that we're solving there, so that we can have these alternative quantifier definitions, and once we have those, then we can characterize the QCats using a logic that's interpreted in QCats. And the reason to use QCats is because quantals are the basis for semantic interpretation for linear logic. So this would give us an alternative axiomatization of linear logic, or the containers for linear logic. So it would the semantics and the logic would have the same relationship to each other as ZF and sets have relation to each other. So the logic that's used to describe sets and i.e. in which we express the axioms of ZF and the container sets, right? So that has that same kind of relation. So that's what we're aiming for And this is kind of the piece of the puzzle where we're still calculating in order to get everything to work out. Any questions or comments?
Good
guys
work,
hear me?
Greg. Yeah,
Yeah, we hear you.
Yeah, that's good work.
Oh.
You and
Well,
Mike are working on.
it's like it feels like we make a little, a little bit of progress, and then we kind of get stuck, and then we make a little bit of progress.
Yeah.
That's just how research is, right? I mean,
Yeah, that's right. Yeah.
the is
all right.
important in the research, but
Yeah, that's right.
you keep doing it again and again.
Yeah, that's right.
Until you get there. But yeah, so I know you have a party to go to.
Yeah.
Are you going to be at the Dev Stand-Up, or should I just?
Yes, I'll be at the Dev Stand-Up, but I'll just be, an observer.
Okay.
Yeah, I need to get up to the soiree now. So.
Yeah. Well, enjoy and have great success. How was the day today? Was it good?
The day was great. The day was really, really good. Yeah, it was very good. Thanks for asking. Yeah, we've gotten a lot of engagement, a lot of interest from potential investors, from journalists, and from other blockchain projects that might be interested in using our technology.
Excellent.
Right.
Excellent.
Yeah.
Well, have great success
right.
and enjoy. I'll see you in a little bit, I guess.
Yes. Ciao, ciao.
Thank you.
See you.